Alright guys, we're back. We're looking at polynomial division today. This is section 8.3.3. This is probably going to be on the longer side because we're going to work through a bunch of examples since this is something that can be a little tricky and that is probably something you're going to need to practice. So the examples below show two methods for dividing this fourth degree polynomial by x minus 2. In both cases the remainder is written as a fraction. So from the last notes we know we could check this if we wanted to and see whether or not we would have a remainder and whether or not 2 is in fact a root by plugging in 2. So why don't we just start with that just to see if we have a root or whether or not we're going to end up with a remainder when we do that. So our remainder theorem said that we could plug in 2 for x, and that would give us our remainder for this division. So let's try that out. So 2 to the 4th is 16 minus 6 times 8 plus 32 minus 1. So 16 minus 48 plus 32 minus 1. And that gives us negative 1. Although I do see right now that I had a little math error right here. 18 times 2 is not 32, it's 36. So instead of negative 1, our answer is going to be positive 3. So we should get a remainder of 3 when you do this, which is a nice little check on your work. Let's see what we get. We're going to start off with long division, and this algorithm is going to be very similar to the long division algorithm that you learned in elementary school for numbers, but now we're applying it to polynomials. So in this first square, we're going to say what times x gives us x to the 4th, and your answer should be x cubed. So we multiply x cubed times x, we get x to the 4th. We multiply x cubed times negative 2, we get negative 2x cubed. We need to subtract that, which gives us 0 here for this, and negative 4x cubed under positive, negative 4x cubed right there. So we now ask, okay, what times x gives us negative 4x cubed? Well, that's negative 4x squared times x gives us negative 4x cubed. Multiply that by 2, which will be plus 8x squared. Subtract those. We end up with negative 8x squared. We keep repeating this process, so I need to multiply by negative 8x to get negative 8x squared. Bring down the 18x. Subtract those. So to get negative 18, I need to multiply that by negative 18. Let's try that again. Negative 18x. And that's going to be plus 36. And that gave me a remainder of 35. So I made a mistake somewhere. Okay, so I found the mistake. We're going to go back a few steps here. So we bring down our 0x squared here. That gives us negative 8x squared here, which I do need to multiply by negative 8 to bring down the 18x here. So negative 8 times x. Negative 8x times x is negative 8x squared. Negative 8x times negative 2 is positive 16x. Need to subtract those. That becomes 0. this becomes 2x, bring down the negative 1. So I need to multiply that by positive 2, which makes this 2x minus 4. Subtract those, and I end up with 3 as my remainder, which I can write as plus 3 over x minus 2. Alright, so be careful when you're doing that. Simple multiplication errors, just like up there, I'm having a bad day with multiplication, can come back to haunt you. So let's take a look at doing the same exact problem using the area model. Again, we should still end up with a remainder of 3. And it was nice, actually, that we started by finding the remainder because it let me know that I did the problem wrong the first time. So here's our area model. Oh, I forgot to cover the answer up on that one. We'll cover the answer up there. And we're dividing that 4th degree by x minus 2. So this x to the 4th minus 6x cubed plus 18x minus 1 is going to become the contents of these boxes, okay? So the first thing we're going to start with is our x to the 4th. I'm just going to go in the top left box. And we're going to start filling this out the way that we would, a normal area model. I'm going to ask myself, x times what gives me x to the 4th? Well, x to the 3rd. Now here's the real trick. These two boxes are going to add up to negative 6x cubed. So let's continue with our area model here. Negative 2 times x cubed is negative 2x cubed. And I know that these two have to add up to negative 6x cubed, which must mean this one is negative 4x cubed, which is going to let me move on to the next term. So I'm going to say x times what will give me negative 4x cubed. Well, that's negative 4x squared. Fill in this next part down here, which is going to be positive 8x squared. Now these two boxes are going to combine to give us positive 18x. So if this is 8x, this must be I was going to say 10x squared, but now I'm looking at the problem here and you can see right away that our x squared term is not 18x squared. That's our x term. That's our linear term. So that's going to be these two boxes. In fact, this must be negative 8x squared because our x squared term is missing in our original problem and is 0x squared, which means this must be negative 8x, and then negative 8x times negative 2 gives us positive 16x. Now we're into our linear terms, our x to the 1st, which have to add up to 18x. So this must be plus 2x. And in order to get 2x in the box, we have to multiply 2 times x, which makes this negative 4. And because that wasn't 0, we know these two have to add up to negative 1, which means this has to be plus 3 for our remainder. Another nice check here, guys, since we did two methods, is that, of course, we should get the same answer for both methods. So this should equal that. So we need to add our remainder here of 3 over x minus 2. And we're good to go on that for our answer. So what does that mean? It means that if we divided this original fourth degree polynomial by our first degree polynomial there, then we get this as a result, and this whole thing could be viewed as a factor. So x minus 2 times our result will give us the x to the fourth minus 6x cubed plus 18x minus 1. Alternatively, you could write the 3 outside of the parentheses, meaning that it would you would not have to write it as x as 3 over x minus 2. Okay? So let's look at some more examples. I'm going to go back to 889 when we were doing this, and we're going to look at a couple examples here. So in part A, they give us a fourth degree polynomial. We're not missing any terms. We have our x to the fourth, x to the third, x squared, and x to the first, and our x to the 0. We're dividing by those two those. Alright, so the first thing I'm going to do is test to see whether or not we're going to get a remainder for this. So I'm going to take my 3x minus 1, make it equal to 0, so that I have 3x equals 1, x equals 1/3, and I'm going to test to see whether 1/3 is a root by plugging that into my original equation. So 6 times 1/3 to the fourth minus 5 times 1/3 cubed plus 10 times 1/3 squared minus 18 times 1/3 plus 5. That's going to give me 6 times 1 over 81 times 5 times 1 over 27 plus 10 times 1 over 9 minus 18 times 1/3 plus 5, 6 over 81 minus 5 over 27 plus 10 over 9 minus 18 over 3 plus 5. Now I'm going to pause the video, do a little number crunching, and get back to you. Okay, so I'm back. So I gave everything a common denominator of 81, added it all up. You do in fact end up with 0. So this 1/3 should be a root, and 3x minus 1 should be a factor. So let's see if that works out and if that's true, which it should be as long as you don't make any mistakes. So I don't make any mistakes. So we're going to go ahead and set up an area model. We're going to have 3x minus 1. I'm going to leave this a little open-ended right now. And in this top left square, I'm going to put 6x to the fourth. And I'm going to ask myself, what times 3x gives me 6x to the fourth? Well, 2x cubed should work. And that'll be negative 2x cubed. And now remember that I need these two boxes to add up to negative 5x cubed. So that's going to be negative 3x cubed, which means this has to be negative x squared, because negative x squared times 3x gives us negative 3x squared. This would then have to be positive x squared. This box and this box need to add up to that term. So this must be 9x squared, because 9x squared plus x squared gives us 10x squared. 3x times 3x is 9x squared. This box must be negative 3x. Remember that this plus this have to equal that, which means this is negative 15x, because those two add up to negative 18x, which means this has to be negative 5, because negative 5 times 3x gives us negative 15. That then becomes positive 5. And this box plus this box have to add up to 5, which they do. This would be my remainder here, which is 0. So that is our answer. 2x cubed minus x squared plus 3x minus 5. Okay, with the remainder of 0. Part B sure looks familiar. Where have we seen that? Part C looks like they want us to do it long division style, which we can. If we do this long division style, we're going to say x squared. We'll zoom in a little bit on this. X squared times x is x cubed. X squared times negative 3, negative x squared. Subtract both of those. 4x squared minus 14x. Bring that down. So this has to be plus 4x to get 4x squared minus 12x. Subtract both of those. That gives me negative 2x plus 3 after it comes down. Then, so we've got to do minus 2 minus 2x plus 6 gives us a remainder of 9. Okay, so then this could be rewritten as x minus 3 times x squared plus 4x minus 2 plus 9 over 3 minus x. Remember that ultimately what we're going to do, these are two polynomials being multiplied by each other, so if I distributed this to each of the terms, that remainder could pop out. We could write it like this, and that would also work. Alright, I think we've gone on long enough here, guys, with these examples, so try to do part D on your own. The hint I will give you is that this really looks like this.